Reports of aerial anomalies spiked during World War II, with Allied pilots describing glowing orbs known as Foo Fighters. By 1946, a wave of sightings across Scandinavia focused on ghost rockets that appeared to streak across the northern skies. These encounters were terrifyingly unpredictable. The objects appeared suddenly, performed maneuvers that defied known aerodynamics, and vanished before they could be intercepted. This era gave birth to ufology, a civilian attempt to investigate these phenomena. However, the field was immediately met with rejection from the scientific community. Academia dismisses ufology because it lacks the core requirements of the scientific method. These events are geographically random, impossible to reproduce in a lab, and almost never leave behind tangible physical evidence for analysis. This created an investigative paradox. Astronomer Carl Sagan observed that reliable sightings are typically uninteresting, while the most extraordinary and interesting cases are notoriously unreliable. The phenomenon lacked the hard data necessary for formal study. To solve this, researchers like J. Allen Hynek pivoted their methodology. If they could not capture the physical objects themselves, they had to systematically categorize and analyze the witness reports as a dataset. Geographic pattern recognition became the only viable framework for study. By moving away from the individual object and focusing on spatial clusters, researchers could look for evidence that witness anecdotes alone could not provide. Logging thousands of isolated sightings over several decades allowed for the creation of a macro-level database of coordinates. Legitimizing the study of the unknown required investigators to move from observing the sky to plotting data points on the ground. During the Cold War, defense departments tracked these anomalies to identify any advanced Soviet aerospace technology that might be entering their airspace. This strategic concern produced massive state-sponsored datasets. In France, the National Space Agency CNES established the GEIPN division to provide a formal channel for research into unidentified aerospace phenomena. Although many official programs were terminated by the 1970s, they succeeded in institutionalizing the systematic tracking of aerial anomalies. Federal defense requirements had effectively compiled the largest spatial dataset of unidentified objects ever recorded. In 2023, the RAND Corporation applied modern data synthesis to this legacy, conducting a comprehensive review of 101,151 public UAP reports. This map visualizes over 100,000 civilian reports across the United States. Researchers applied filtering metrics, discovering that sightings were less likely to occur within 30 kilometers of weather stations. Report rates also decreased near airports, commercial flight paths, and densely populated city centers. With urban areas removed, the data revealed a clear trend: sightings concentrated in remote rural clusters. The study's most significant finding was that these rural clusters sit overwhelmingly within 30 kilometers of established military operations and routine training areas. This geographic alignment identifies the phenomenon as a measurable event tied to defense infrastructure, rather than random civilian reporting. The statistical reality of the RAND map contrasts with the cultural distractions of ufology, often linked to agricultural hoaxes and elaborate science fiction narratives. Subcultures involving extraterrestrial cults, Posadism, and alien abduction claims have historically derailed academic inquiry into aerial incursions. However, the volume of available geographic data has now forced governments to separate the stigma of the fringe from the physical reality of airspace safety. Securing national airspace now requires treating these occurrences strictly as a matter of aerospace forensics. Modern astrophysics is deploying physical sensors to capture data. Harvard's Galileo project, led by Avi Loeb, seeks to replace human eyewitnesses with continuous telescopic observations. Global academic interest is increasing, with the University of Würzburg developing intelligent AI sensors designed specifically to detect unidentified aerial objects. The bureaucratic validation of this research culminated in 2023, when NASA appointed an official director of UAP research to coordinate their investigation. The coordinate map, built over several decades, finally forced human institutions to look at the sky and admit that unidentified phenomena are operating in our own atmosphere.